Maps in Go. So, map in Go is based on a hash table data structure. So, inside map, it contains of array of buckets, and each bucket has 8 elements, and each element has a top hash, key, and value. Top hash is needed for a quick search inside our bucket. So also each bucket has a bucket overflow reference, and it has a reference to another bucket for the cases when a bucket is overflow, has over than 8 elements, and we need to put another one. So when we pass the key to map or look for a value by key, Golang first calculate hash function from the key, and then it takes low order bits of hash value, and the count of low order bits equals to logarithm of count of all buckets in map. And when the bucket is found by low order bits as index, Golang starts to look for an element inside of bucket, and inside of bucket it first compares top hash of each element and first 8 bits of calculated hash value. When the element found by top hash, Golang starts to compare key of element and the past key. If the element is not found in bucket, Golang gets to bucket overflow reference and repeat the same steps with top hash and keys for elements in bucket overflow. Also, there might be situation when when average count of elements in all buckets is over than 605, which is a so-called load factor constant. Then Golang creates twice greater count of buckets for the same map, and these buckets are not populated immediately. They are populating when you change or remove elements in a map. So map passed by reference, meaning that changing elements inside of function, removing or saving, will reflect on outside map. on past map. And reassigning the reference inside of function will not reflect on a past map, on the source map. So reading from non-initialized map will return 0 value for type, and writing to non-initialized map will lead to panic. In map, the key could be almost every type in Golang except map, slice, and function. Speaking of thread safe in map, it's not a thread safety type, which is why we should use mutex or rv mutex while working with it. And let's compare sync map and mutex. So, and the simple map on mutex. So the sync map in mutex guarantee us thread safety, but it works with interface types, so you should cast keys and values to the appropriate type, so there is no compilation verifications. And sync map should be used for 2 reasons. The first one is when you have a situation when you need write once to by key but read a lot of. So I used it to implement thread safe local cache, for example. And the second upline is when you have several coroutines and each coroutine should use a separate subset of map. So to make a set in Golang, you should use a the same map but with the empty struct as values. And example of using maps, simple maps in Go might be deserializing JSON file or reading data from API and mapping it to model as a map type.